Hey everybody, this is Unit 2, Video 7, and we're going to be covering arc length and area of a sector applications. I'm going to give you 3 examples here, 2 of arc length applications and 1 of area of a sector. You'll find more in the textbook along with the worksheet, I'm unable to do an example of every single type of problem, so you're going to have to work together to go beyond the 3 that I show you an example of here. So just a little review, our arc length measured or labeled S is in radians theta times r, or in degrees is going to be 2 pi r times theta over 360. The area of a sector, looking for a shaded region or an included region of the circle, is in radians as well, is going to be measured as theta over 2 times r squared, or with degrees is going to be pi r squared times theta over 360. So just be sure which one you know which formula you're going to be using before you start substituting numbers in for the variables. The first example we're going to work with is a gear or a pulley example. Here we have 2 gears that are working together as they rotate. That means that the circumference of one gear is touching the circumference of the other. It's touching the perimeter. And as the small gear rotates, the distance around the gear is being laid onto the other one, for example. It's peeling off onto the other. Imagine one has paint and the other doesn't have paint on it. So as one rotates, the other one is being touched the exact same amount. Okay? The small gear has a radius of 4 inches. And the larger gear has a radius of 7 inches. If I were to place a circle around the edge here, that's our circumference of the small gear, and that were to peel off, okay, if it were to paint, it would be painting the other gear as these rotate. It would paint a portion. Well, that portion is what we're essentially looking for, is we want to know how much that is so that we can apply it to our formula. I'm going to use the formula for degrees in this particular case. And our portion for degrees, or our formula for degrees, is 2 pi r times theta over 360. Now, since I'm actually stating that these two will share an arc length because the circumference here is wrapped around this one as it rotates, so I'm actually going to be setting these equal to each other, but I just have different angle measures and different radius measures. So let's say that this is gear 1 and this is gear 2. I know that gear 1, the small gear, is rotating one complete rotation. I want to know what is the angle in which the larger gear, gear 2 here, rotates if the other one goes completely around. And as you can imagine, the smaller gear goes completely around, the large gear does not, so it will be less than 360 degrees. So I'm going to change colors as I go ahead and place these values inside. So I will have 2 pi times my radius of the small one, which is 4, times 360 over 360, which is one complete rotation. On the other side, I've got 2 pi times that radius, but I don't know how far it's rotating at 360 degrees. So my goal is to solve for that theta. On both sides, I have 2 and I have a pi, and those both can be eliminated, as can the 360s. Because they're on both sides, that means they're equal. That means I'm able to go ahead, and if I were to multiply both sides by 360, they'd both disappear. If I were to divide both sides by 2, the 2's would disappear. So I'm simply left with 4 times 360 equals 7 times the angle I'm missing. If I divide this side by 7 and go ahead and use my calculator to do so, I would have 4 times 360 divided by 7, which leaves me with an angle value measured in degrees, because I use the degree formula, to be 205, 205.7 degrees. It is an approximation, but that's fine. So, as the small gear rotates 360 degrees, the large gear rotates 205.7 degrees. Let's try another example. This one discusses latitude and longitude. In this case, we're going to be discussing longitude, which goes north-south. Find the distance between the cities to a nearest kilometer. Assume the cities lie on a north-south line and the radius of the Earth is 6,400 kilometers. So I want to go to the nearest kilometer. I'm trying to find the distance. So I'm going to use this image that I have here to help you out. I don't have South Africa or Israel on this particular piece of clip art, but if we were to make an example of, say, a city up here, Chicago, and somewhere down here in Mexico, they would be along perhaps the same line of longitude. So I would be able to find this arc length on the Earth to find the distance between those two cities. So we are assuming that Johannesburg, South Africa, and Jerusalem, Israel fall on a north-south line, one line of longitude. And we're looking for the distance between them. Well, since Jerusalem is north of the equator and Johannesburg, South Africa is south of the equator, here's the edge of the circle, which being the Earth, and this gives us our entire central angle, which would include 32 north and 26 south for a theta value of 58 degrees. So since we're measuring this in degrees, and I know my radius is 6,400 kilometers, we're going to use 2 pi r theta over 360. And if I substitute my numbers in, I get 2 times pi times 6,400 times 58 divided by 360. Since I'm working with a word problem and it asks for the nearest kilometer, I'm going to enter that in my calculator exactly as I see it. That gives me 2 times pi times 6,400 times 58 divided by 360 degrees. And it says the distance between Johannesburg, South Africa, and Jerusalem, Israel is approximately 6,479 kilometers, and that is to the nearest kilometer. Okay, I have one more example here, and this is going to be working with an area of a sector. As a member of the mural club, you are responsible for painting the background for the mural on a wall in the school cafeteria. The background requires a circular sector with a central angle of 120 degrees and a radius of 9.3 feet. If a quart of paint covers 20 square feet, how many quarts of paints are needed for the background? Well, before we can determine how many quarts of paint to buy, we probably should figure out how big our area is. So I've been given here the area formula, or the angle measure in degrees, which leaves me with theta equaling 120 degrees and a radius of 9.3 feet. I'm going to be using the formula pi r squared theta over 360, and I'm going to substitute the numbers in. Pi times 9.3 squared times 120 divided by 360. Because I'm actually going to need to calculate the number of square feet in order to buy the right number of quarts of paint, we're going to want to actually type in the pi and get an exact answer, or an approximate answer. So 9.3 squared times 120 divided by 360 times pi leaves me with 90.57 square feet. Now this is an approximated answer, but that's fine. If each quart of paint covers 20 square feet, I would need to buy 5 cans of paint. I got that from dividing 90.57 divided by 20, which leaves me with 4.5, and since I can't buy half a can of paint, I'll have to buy the 5th can. All right, go ahead and proceed and look at the other examples that you'll find on the worksheet and in the textbook.